In this video, we're going to look at a couple of different polynomial functions and look at how to go about solving for all of their roots and then taking that information to sketch what the graph would look like. So to start, I'm giving you a function that's already in factored form. So this is kind of nice. I don't have a whole lot of work to do. The first thing I'm going to do is I'm going to change out that p of x for a 0, and all of my exponents I'm going to expand. So what I mean by that is instead of x squared, I'm going to actually write x times x. There's only 1x plus 1, and then I have 3x plus 4s. Okay, now I'm really just dropping and splitting, which is what we would have done if we were solving a quadratic. We just have a lot more factors. So what you can do is draw a little line to the best of your ability through each individual x. Every x marks another root. So in this case, if I set negative x equal to 0, really x is just equal to 0. I'm going to get another x equals 0 from this x, so that means there's 2 of those. This would give me x equals negative 1. All my signs just flip because they're set equal to 0. This would give me negative 4, and I'm going to get that 3 different times. Okay, so the roots that repeat, if you remember, have a special shape they're going to make when you sketch the graph. So because 0 repeats 2 times, that's going to make what we call a turnaround on the graph. You can also abbreviate this as just TA. That means when you hit the graph at 0, the graph is actually going to just turn around, almost looks like a little parabola. X equals negative 1 only occurs once, so we actually call that a pass-through. Again, if you want to abbreviate, you can just call it a PT. Okay, and then finally, we've got negative 4 happening 3 times. We call this in our class a saddle point. Or again, if you want to abbreviate, you can just call it SP. That's where the graph really just sort of flattens out and then keeps going. So right now we've got all of our root behavior, and now we want to figure out a couple of other things. So if you remember if you've seen the graphs of polynomials video, it's important to know if the function is odd or even, negative or positive. So if I go back and look at this, since I have a negative at the front, this is definitely a negative function. And since I do have a total of 6 roots, that means 6 is an even number. This is an even function. Okay, so why do I care about that? That's going to help me figure out what quadrants this function starts and ends in. So a negative even has a sort of general shape like an upside down parabola. Obviously this one might not look exactly like a parabola, but at least I know that I'm starting in quadrant 3 and ending in quadrant 4. You don't have to put the s and the e on there, but it's a nice little guide. The other thing we sometimes do with these functions is, if possible, we go to the table in our calculator and we figure out where the y-intercept is. It just gives us one more point to graph, and if it's a reasonable number, we'll put it on our graph as another point. So if you've done that, hopefully you found out that the y-intercept of this function is 0, 0. So I actually already knew that because I'm going to be putting a root at 0 anyway, but that's okay. Still worthwhile to look for it. So I should have a dot at 0. I should have a dot at negative 1. And I should have a dot at negative 4. Okay, so if you can kind of visualize what this will look like, I'm going to start my graph, start the first piece of my graph in this lower left quadrant, and I'm going to go up, do a saddle point at negative 4, just pass through at negative 1, and do a turnaround at 0. So it should look something like this. This isn't perfect, but you should have something like this. If you're ever worried that I'm not going to be able to tell, or your teacher won't be able to tell what you're doing at each spot, you can always label them. I can say, oh, this is a saddle point, in case you can't tell. This is a pass-through, and this is a turnaround. You don't have to label those, but again, it's something you can do just to make sure that the teacher knows what shape you were trying to draw. So that's a sketch of that function after all the roots have been found. Here's another function, polynomial function. It's not been factored, so we're going to have to factor it ourselves. So that's one option. You can always start by trying to factor your function, or you can go to the calculator, which I'll explain in a minute. So in this case, I see the first thing I can do, actually, let's go ahead and set this equal to 0, like we did with the last one. Because usually when we're solving equations, they're set equal to 0. And now I'm going to look for anything that they have in common that I can pull out. It turns out that all of these terms have an x in them, so I'm going to go ahead and pull out an x. So that means every term is getting divided by x, and I'm left with x cubed minus 4x squared minus x plus 4. So every term loses one of its x's. Okay, so now I'm down to a cubic function. What I can try to do now is factor by grouping. So if you remember how this works, you're going to break your 4-termed polynomial into 2 chunks, and you're going to try to factor a GCF out of each one. So what you've kind of got happening now is you really already have this one x on the outside, and now you're pulling another GCF out of this. So the GCF between x cubed and negative 4x squared is x squared. So that's the GCF, and when I divide both terms by that, I get x minus 4. Okay, between negative x and 4, they really don't have anything in common, but because that third term is negative, I'm going to go ahead and pull out a negative, or a -1 you can write. And then that changes my x to a positive and my 4 to a negative. Okay, that means my factor by grouping worked because I got that matching binomial, which is what I'm supposed to get. So I'm going to sort of continue on factoring over here. Now I have that x on the outside. I'm going to put my 2 GCFs together and my common binomial together. And I'm still equal to 0. I just moved it over because I didn't have space on the left. Okay, I can actually factor one more time. If you notice, this second factor is actually dots factoring. So I can go ahead and square root both of these and break down one more time into x minus 1, x plus 1. So from here, I'm fully factored, and I can go ahead and drop and split, just like I did in that last example. And I'm going to get that x is 0. That's one of my solutions. That's going to be a pass-through because it only occurs one time. Here, I'm going to get x is positive 1. Again, that's a pass-through. This third factor is going to give me a root of -1. Another pass-through, and finally a root of -4. So these are all pass-throughs. So you have 4 distinctly different roots, and your graph is just going to go through all of them one time. So I'm going to go ahead now and label my function before I start graphing. Remember, I need to say if it's positive or negative, odd or even. I'm going to kind of go up to the top left corner of the screen. Since my highest power is 4, and I have 4 roots, this is an even function. And since I have no negative at the front, this is a positive function as well. If you want to go ahead right now and type that function into your calculator, we can find out where our y-intercept is. Hopefully you found that yet again our y-intercept is at 0, and that makes sense again because we do have a root of 0, so we knew we were going to have a dot there. Okay, so I'm going to go over to my graph and label everything. So I have a dot at 0, I have a dot at 1, -1, and -4. Okay, since it's a positive even, that's going to look sort of like a regular parabola, something like this. So I'm starting in the second quadrant and ending in the first. So I'm going to go ahead and just do 4 pass-throughs. So you should get something like that. Again, you can label each root behavior if you want to. You don't have to. All of these are pass-throughs. So if you want to just write little PTs here, this is not necessary. Just if you're afraid that whoever's grading is gonna have a hard time telling what you have. So that's a sketch of that function. Why don't we look at one more? Okay, so here is an equation. I can do what I did last time. I can start out by setting it equal to 0 and trying to factor. However, since this is a cubic function with 4 terms, you could try to go ahead and start factoring by grouping like we did before. But I think you'll quickly see that you're not going to get matching binomials. You could start getting all the way through this. If you factored out an x squared, you'd have -x minus 5. And over here, you'd probably be factoring out a -3. And I'd be left with x minus 3. So you can see, if you've gotten this far, these binomials do not match. They're really not even close. So that means factoring by grouping fails. So you cannot factor this in its present form. So what do? Okay. Well, we use our calculator as a resource. What you should do now is pause the video, go ahead and type r of x, that function, into the y equals button on your calculator. So if you did that, hopefully you see what I see in this little screenshot of my calculator. I've circled 2 different places where I see a root. If you see a 0 in the y column, you know that that's a root. So at this point you have a choice. You can choose either of these to work with. I'm going to go ahead, since I see -3 first, and I'm going to go ahead and plug that in using synthetic division, because that's going to help me divide by one of my roots and break down my polynomial a little bit. So remember, with synthetic, I'm listing out my coefficients. I'm a little squeezed over here. So hopefully you can follow this. I should definitely be getting a remainder of 0 because I've seen from my calculator that this is definitely a root. So I drop down my -1, I multiply to get +3, I add down to get -2, I multiply to get positive 6, then I add down to get positive 3. When I multiply one last time, I get negative 9, and that does in fact get me my 0. Okay, so that's great news. So I've got one of my roots. So remember later when we go to graph, we've already found one root. So since this is a degree 3 polynomial, I have 2 more to find. That should be pretty easy to deal with because this right here actually can turn into a quadratic function. So since the remainder is 0, this is really the function negative x squared minus 2x plus 3. I think your best bet here is to just do a quick MAM on this. I will, however, just divide everybody by -1 first. It's a little confusing to try to do MAM with a negative x squared. So this is really x squared plus 2x minus 3. So if you do MAM to this, you need to multiply to -3 and add to 2. Hopefully you recognize that this would be x plus 3, x minus 1. And if you do a final drop and split here, you're going to get a root of -3 and positive 1. Okay, so if you just look, remember we found that -3 before, so we really have the root -3 2 times and the root positive 1 once. So that means -3 on our graph will be a turnaround and positive 1 will be a pass-through. Okay, so that gives us that behavior. If you take a look at that little screenshot I showed before, you can also see your y-intercept. If you see 0, 9, that's going to be a point, if I have space, that I'll plot on my graph. I don't know if this graph goes to 9, but if not, you can sort of just put it where you think it should be. And finally, I need to also state if this function is positive or negative, odd or even. So if you go back to the original function, I see that negative, so it's definitely a negative function, and we said this is a degree 3, so it's odd, which means that I should be starting in quadrant 2 and ending in quadrant 4. Okay, I'm going to go ahead and label. I would have one root at -3, one at positive 1. My axis actually does not go up to 9, so I'm just going to sort of put it up here. I know this isn't perfect. If you're following along at home, hopefully you have a little bit more space. Okay, so just talking through this for a second, remember that you're going to come down and do a turnaround at -3, and then go back, hit your y-intercept, and go back through positive 1. So you should look something like this. Here's my turnaround, I hit my y-intercept, and I go straight through at positive 1. So we get a function that looks like that. So that hopefully was a good overview of different types of polynomial functions you can be given, how you can deal with them, and eventually come up with a sketch of their graphs.